Hi all, welcome to my channel Data Wisdom. In this video, we are going to discuss about different partition components available into AbInitio. We use these partition components to split huge data into multiple partitions and process them parallelly. So before going through this video, if you have not watched our previous video on multi-file system and parallelism, kindly go and watch that video first. So I'll paste the link for that video in our description box so that you can go through that video and understand the concepts better, which we are going to discuss into our current video. And needless to say, kindly subscribe to our channel. Will motivate us to create such kind of videos and contents which might be helpful to you, right? Let's start. So if we talk about partition components in AbInitio, below is the list of components which are available and which we can use to partition our data based on our requirement. The basic list goes as partition by expression, partition by key, partition by percentage, partition by range, partition by round robin, and partition by load balance. So we'll go through these components one by one. We'll understand how does these component work and what is the benefit of using these components and when to use which component. Basically, that would be our basic idea of implementing this in our practical session. So let's go to our AbInitio GD. We have already created a graph and we'll go through all these components one by one and we'll see what is the difference between these components when they partition the data. Okay, so let's go to our GD. So we have already created this graph to keep our video short. Okay, so let's first view the data of our source file. So source file will remain same for all the partition components and we'll see how differently it partitions data into different partition. Okay, so this is my serial file. We'll quickly have a look at our data. What kind of data is available into our source file. So there are totally 12 records which we are going to use as our source records, and we'll see how does this partition components divide data into different partitions. Also, for our target, we are using two-way MFS file. So basically it will have a control file and two data partitions, and we'll see how does this partitioning works. Okay, so let's go with our first component, which is partition by expression. So we'll go to parameters. So we have a parameter called function over here, right? So if you want to write any kind of DML expression based on your input file, right, whatever columns are available into your input file, you can write an expression over here. You'll just have to click edit. All the input files will be available, all the functions or operators which you can apply on those attributes will be available over here. So you have to write an expression such as it evaluates the value between 0 to the number of partition minus 1. Okay, so it should evaluate a value like that. The value should start from 0. It can start from 0 and it should be less than the partition count. So if we have two partitions, what my expression could result is in 0 and 1. If it results in a value 2, my graph will fail because the second partition number 2 will not be available. So I say that we have a two-way MFS, our partition count will be partition 0 and partition 1. Okay, so your expression should result into either of them, either 0 or 1, and whatever is the value which is evaluated by this expression, your record will go into that particular partition. Okay, so I'll disable these components now and we'll run partition by expression. Okay, so let's run our graph. So we have already seen our input file. Let's quickly open this input file. So it has 12 number of records with different IDs. Okay, and the amount field, the expression we have written is ID greater than 30. Okay, so ID less than equal to 30 will go into a single partition and ID greater than 30 will go in another partition. Okay, is this, and I'll run the graph. Evaluation is done, and we had 12 input records, and into output also we have 12 records. Now we'll see the data of our output file. So first we'll see data of partition 0. So if you want to see any particular partition data, you will just have to click on this partition radio button, and from drop down you can select which partition data you want to view. Okay, so we are going to view partition number 0. So we'll have 10, 20 and 30 IDs available over here. Why? Because if we'll see our expression, what expression we have written, ID greater than 30. That means whenever this condition is true, result will be 1. Whenever this condition is false, the result will be 0. So for all these IDs, this expression evaluates to 0. So these records have flown into partition number 0. Okay, now let's view data of our partition 1. So ID 40 and 52 should be available into partition 1. Okay, now let's go to our second partition component, which is partition by key. I will enable this. I'll disable this particular portion of our graph. Okay, now again source file is same, the same number of records and same IDs and amount. Okay, now what we are going to do, we are going to configure our component partition by key. So here you have a parameter called key. Okay, when you double click on it, you will have all the columns or all the attributes available into our input DML to select as a key. Now from here you can select a single key or a composite key. So if I want to partition my data based on ID and amount both, I'll click on both the columns. If I want to remove amount, I'll remove it from here and I'll click OK. So my key becomes ID. Okay, now how does it work? Whenever you have selected a particular key, right, this partition by key component internally will generate some hash value or some internal value based on that key. Okay, and all the keys which have the same values. So if we look at our input data, right, so we have multiple records with IDs 10, 20, 30, right? So what it will do basically is it will create a hash value, and the hash value will be same for all the records with ID 20. For ID 20, it will be the same. ID 30, it will be the same, right? And based on this hash value, now how does it know which partition should I throw this particular data to? We have two partition 0 and partition 1. Now how does AbInitio evaluates which ID should go to which partition, right? We cannot identify this first. We cannot decide which partition will this particular ID with value 10 or 20 will go. But yes, whichever partition this value goes, suppose this ID 10 goes to partition 0. So all the records with this ID will go to partition 0 only. It will not happen that two records of ID 10 is in partition 0 and two records are in partition 1. That will never happen. Okay, because the hash value will be same for all the records with similar ID. Okay, now the other way could be, suppose it is calculating a hash value and now it will divide that particular hash value with the number of partitions available. Okay, now suppose for this it has created a hash value. Okay, the hash value for 20 will be different, 30 would be different, 40 and 52 would be different, but the number of partitions based on our output file layout, it is fixed. So we are using 2-way MFS. Now whenever you divide that hash value with number 2, because we have two partition, what would be your reminder? It would be either 0 or 1. Okay, now whichever hash values, when we divide it by the number of partition, has the same remainder, it will go to same partition. Okay, so suppose 10 and 20, right? Now suppose 10 has an hash value of 1, 20 as 2, 30 as 3, 40 as 4, and 52 as 5. Okay, now we'll divide it with number of partition. So it has a hash value of 1. Divide it, what would be your remainder? It will be 1, say. Okay, so it will go to partition 1. If you divide 20, your remainder will be 0. It will go to partition 0. 30, again your hash value is 3, right? If you divide it with 2, remainder is 1. It will go to partition 1. It is just an example what I want to tell you. Okay, so we'll see how does it operates. Okay, so that is one way to tell which partition this value will go, but again we cannot tell which hash value ab initio has generated internally, right? This is just a concept, like which partition it could go. Okay, so let's run the graph and see how does it partitioning our input data into two different partition if we are using partition by key. Okay, so my graph is executed. Again we'll see our data. Okay, so I'll see partition 0. Okay, so partition 0 has value 10, 30 and 40. Okay, now we'll go to partition 1. It should have the other two keys which are missed, right? 20 and 52, right? So if we'll see what are the benefits and what are the cons of using partition by key, we'll quickly do data for both the partition and then I'll describe. Okay, now here I cannot tell which hash value has ab initio generated, and by dividing that value with this number of partitions, it has distributed our data. Okay, now if you'll see both the partition 0 and partition 1, right? What's happening? Partition 0 has more number of records and partition 1 has less number of records. If you'll see, it's almost 70% records available into partition 0, 30% records available into partition 1. So it is creating a skew, right? Skew means one partition has more data, second partition has less data. So whichever server is processing partition number 0, that will produce records a bit late because it has more number of records to process. Whereas partition 1 has very less number of records and it will give me the results much more quicker. Okay, so that's basically con of using partition by key. But whenever we are partitioning our data and we are going to use any key based component after this partition by key, suppose I'm using rollup or join, right? In that case, I want the same key data to be present into a single partition. I do not want that 3 records of id 10 should be here and 1 record of id 10 should into partition 1, because then it will not give me proper result after joining or after performing rollup, because it will happen on partition by partition, right? So whenever we are going to use any key based component after partitioning our data, we'll have to use partition by key, right? That will ensure that all the records for that particular key are present into the same partition. Okay, but the disadvantage is it will create an skew. It will not distribute my records evenly into all the partitions. Okay, now we'll go through partition by round robin first. Why? Because we have seen how this cube is being created while using partition by key. Okay, now suppose you are not using any key based component after partitioning your data. You are simply going to use, say, reformat or you are going to filter your data, or you are going to use any other component which does not require key based partitioning, right? Or it does not operate on a particular key data, right? So what should our thought process in that case? We should distribute our data evenly into all the partitions so that all our servers, whichever are processing our data, are equally engaged or equally busy. We should ensure that one server should not have much load and other is free, right? So in that case, we'll be using partition by round robin component. Okay, so now what do we configure here in partition by round robin? We configure the block size or number of record it should send to one partition at a single go. Okay, so by using this, how can I ensure that my servers are equally engaged? So if you'll see, I have given as 3, my block size is 3. So what it will do, it will distribute 3 records per chunk. Okay, so if I'll show you input file, what it will do, it will send these 3 records into partition 0, the next 3 records into partition 1, then again these 3 records to partition 0, and again these 3 records to partition 1. So it is equally distributing my data into the partitions which are available to ensure that none of the server is very busy or none of the server is completely free. Okay, but again, so if I have given a block size, then my same ID is distributed across partitions, right? Because since I have given block size as 3, these 3 IDs are going to partition 0, next 3 are going to partition 1. So this record number 4 with ID 10 is going to partition number 1, right? So when you have a key based component to operate after partition by round robin, that would not be a good approach, right? But if you are processing your data without configuring a key in the next component, go with partition by round robin. It will ensure your better performance. Okay, so let's run our graph and we'll then view partition 0 and partition 1 data. Okay, the graph is executed successfully. View our data. Will be partition 0. Okay, so let's see. We have only 3 records with part ID 10 into partition 0. Wherever, if I open partition 1, one record should be present over there. Right? What is happening? First, it has processed these 3 records because our block size was 3. It has sent it to partition 0. Next 3 records with ID 10, 20, 20 sent to partition 1. Then again it picked 3 values with part ID 30 to 0 and the remaining 3 records into partition 1. So it is ensuring both the partitions have same number of records. Okay, there could be a bit less or more records, depends what block size have you given and whether the input records are if I divide it by the block size, it is equally distributed and remainder is 0. If remainder is not 0, the additional records whichever are available, those will be sent to any of the partition, okay, based on the block size. Okay, so this was our partition by round robin. So we'll see our next component, which is partition by range. So here into partition by range component, you will mention based on which key you have to basically split your data or partition your data, and then what is the range. Okay, so you will have to create a split file for this. Okay, so now your split file will be same as your input file. You just have to mention based on a key which we are providing into our parameter, what should be the range based on which it should split the data. So I have given my key range as 20. So what it will do, all the records until ID 20 will go to one partition and greater than 20 will go to the other partition. Okay, so we'll quickly run our graph and see what output does it produce. So in partition by range, we have given our key as id, and for id we have mentioned our split file. Based on that range, it will distribute my data across the partitions. Okay, so we'll first see partition number 0. So what it should have, it should have either values greater than 20 or less than equal to 20, right, based on our range. So if you'll see, it has id 10 and 20 available into partition 0, and in partition 1 we'll be having id 30, 40 and 52, which are greater than 20 or which are out of our range, right? So if we have any specific requirement to use this particular component, if you have a range defined based on which you have to partition your data, you are going to use this particular component while partitioning your data. Okay, and it will distribute your data accordingly into different partitions. Now we'll see our next component, which is partition by percentage. So here we'll define a list of percentage, how many number of records we want to distribute into different partitions. Okay, so there are two ways to define this percentage. First way is to provide space separated values over here. Second way is to provide a file with the list of percentage over here. So I have mentioned percentage as 10, right? So what it will do, divide my records 10% into one partition and rest 90% into the second partition. Now I cannot tell which partition it will distribute your records based on, right? So, but the surety is it will provide 10% records into a single partition and rest 90% into the other partition. Okay, so now let's run this graph and see what do we get. Okay, so, and if you have to provide multiple number of percentage, you can provide it within a space separated list, but the sum of percentage should not be greater than 100. It should always be 100, right? So by default it will take n-1, right? So I have two partition, I have given one value as 10. So what it has done, it has distributed records into two partition, 10% into one partition, rest 90% into second partition. The complete sum is 100%, right? If I have three partition and I am giving 10 and 20, what it will do, 10% to single partition, 20% into other partition, and rest remaining 70% will by default go to the third partition. Okay, now let's view the data. So this is partition 1 for partition. Okay, so this is 10% record. So 10% of 12 will somewhere around 1.2. So it has taken the second record also considered as part of 10%. Okay, so it has given 10% record into one partition, rest 90% records into the other partition. Okay, now we'll go to our, and yeah, before going to next component, if you want to provide list of percentage in this percentage file on PCT port, you can do that. For that, what you will have to do, you will have to create a file. Okay, the DML of file would be a single column which is percentage, and that will be of type decimal. Okay, so like this. So if I have only 2%, right, two partitions, I'll give only 10. That means it will give 10% record into one partition, rest 90 will be into second partition. Suppose I have 4-way partition and I'm giving like this. What it will do, 10% into one partition, 20% into second partition, 30% into third partition, and remaining records will go to my fourth partition. Okay, and I'll connect this file to this PCT port. Then I will not require to give the percentage values into my parameter over here. Okay, it will read the list of percent from that particular file. Okay, now let's go to our next partition component, which is partition by load balance. So this component, we do not need to configure anything over here, right? So if you'll open the parameters, you cannot see any parameter tab over here, right? So what it will do, it will internally check which server can process my data faster, and based on that it will distribute the record. Okay, but there is a possibility that it may send all the records to a single partition as well based on load balancing. So there is a possibility that Suppose you have two MFS and you are processing a data on two server, and one server is already busy with some other process, right? So what my partition by load balance will see, it will see that one partition on one server is completely free, and it will send all the records to that particular partition. Okay, so load balancing in general, right, it will check which server is free, and there it will send the records. First we'll see partition 0. See, it has sent all the 12 records to partition 0 only. Okay, since we are running it on localhost, server will be same for both the data partitions. Okay, so this was a basic concept on our partition components. Hope you understood it. Kindly do comment on our videos if you have any further questions related to or these components. Or so these were the basic partition components which we use into AbInitio, and their description, their runtime behavior. If you want any further videos on these partition components, kindly do comment on this video and let us know. We'll try to create more informative videos for you on AbInitio and on other data engineering technologies. Kindly like this video and kindly subscribe to our channel so that we can provide you more such videos. Thank you so much.